Hi guys, welcome to the test review for Unit 9, and we are going to be talking about just all sorts of things. But right now we're going to start off with sequences, and so it says state whether the sequence is arithmetic, and arithmetic means addition or subtraction. And geometric technically just means multiplication, but like you'll see it'll look like multiplication or division, or neither. And that means it might have a pattern, but it's not going to be addition, subtraction, multiplication, division. If it's arithmetic, find the common difference. So what it's asking you to find is the pattern. And then geometric, so the pattern for arithmetic is common difference, and the pattern for geometric is common ratio. So let's look at this. So, I mean, the first thing that I do is just like make it easy. Like, do I add 3 from here to here? No. So my next thing I'm going to try is multiplication. So I don't know what I need to multiply by 6 to get to 9. So I'm going to do this trick where you take the second number divided by the first number. So 9 divided by 6, and that gives me 1.5. So let me see, so this is 1.5. Let's see, 9 times 1.5, is that 13.5? Yep. Is 13.5 times 1.5, 20.25? Yes, okay. So this means that it's geometric, and that the common ratio is going to be 1.5. That's my pattern. Okay, let's look at this next one. So 6.4, again, I'm just going to see, like, I'm just going to say 8 minus 6.4 to see, let's see, that's 1.6. So 6.4 plus 1.6 is 8. Let's see, 8 plus 1.6, that's 9.6. 9.6 plus 1.6, that is 11.2. Okay, so this is going to be arithmetic. And the pattern is 1.6. Okay, let's see this one. Gosh, I don't know. Let's try, let's see what I'm adding between the two. 87, because 16 plus 87 is 103. So let's see. Oh, look at that. 87 plus 103 is 190. 190 plus 87, let's check that, is 277. Okay, so this is also arithmetic. And it has a pattern of 87. Okay, so in this next part, we are going to write the equation and then find the 7th term for it. Okay, so I look at this one. So this is the same as this. So I know that I'm going to use my reference sheet. So my starting point is 6.4, and then plus n minus 1. And then what was my pattern? Let's see, I'm adding 1.6. Okay, so this is my equation. And then what I'm going to do is I'm going to take that 7 and plug it in right there. And I'm going to plug the whole thing into my calculator. Okay, so when I did that, I ended up getting 16 as my answer. Okay, let's do this next one. So it looks like I'm subtracting 10. Let's see, subtract 10, subtract 10. Okay, so this is also arithmetic. So I'm going to say a sub n equals 8 plus n minus 1 times negative 10. And just like this one, I'm going to plug in 7 for n, and I get negative 52. Okay, and let's do this last one. So this last one, it looks like I'm multiplying by 1 on top because that's staying 2. And then it looks like I'm multiplying by maybe 1/3 on the bottom. Let's see. Yep, that works. So my common ratio is going to be 1/3. And so I'm going to say 2 times 1/3 to the n minus 1 power. And then just like all the others, I'm going to plug in that 7 for n. And I end up with 2 over 729. Okay, let's keep going. So for number 3, I'm going to write an equation for the nth term. That just means we're finding the formula, then find this 37th term. Okay, so basically this is just the exact same thing. So I'm going to, let's see, add 5, add 5, yeah, add 5. Okay, so I'm going to say a sub n equals 13 plus n minus 1 times 5. Okay, so this is answering this part of the question. And then all I'm going to do is plug in 37 for n. Okay, so when I typed that in my calculator, I ended up getting 193 for my answer. Okay, number 4, we're just trying to find the pattern. So let's see, 1, 2, 3, 4, 5. Okay, so this one's 5, this is 5, this is 11, 5, 10, 15, 16, 17. That's 17, 5, 10, 15, 20, 23. Okay, let's see what's going on. Let's see, I'm adding 6 here, adding 6, adding 6. Yeah, how many blocks will be in stage 11? Okay, so I'm going to say 5 plus n minus 1 times 6, and I'm going to put 11 right there. And I end up getting 65 for my answer. So that means that there's going to be 65 blocks. Oops. Goodness. At stage 11. Okay, let's go to the next one. Okay, so again, we're just kind of doing the same thing, except now we're just given different information. So I'm going to use my reference sheet and come up with an equation here. Here's my equation. Something I want to say, let's go back here. So when I came down here, I like this, anytime you have G of n, that's just what the EOC reference sheet uses. If you had A of n but still had the same equation, that's going to be fine too. So don't just assume that it's like just because it's G or A, like that it's arithmetic or geometric, because they flip-flop back and forth. And so just be careful about that. Okay, so the next thing I'm going to do is I'm going to plug in 11 right here. And I end up with 7,168. Okay, and I'm going to do the same thing here. I'm just going to use a sub n. So it's going to look like that. And then again, I'm going to plug in 11 right here. And let's see, I get negative 56. Okay, let's move on to some word problems. So an employee has a starting salary of 40,000. Okay, so that's going to be my first term. And then it's going up by 3,000 every year for the first 10 years. So we're going to keep going for 10 years. Okay, how much will the employee make in year 6? So I like to make an equation. Oops. Okay, so here's my equation, and I'm going to plug in 6 for n, and I end up getting 55,000. So after year 6, they're going to make 55,000. Okay, for this one, remember, money usually is y, so we're going to plug this in here and like what it's set equal to. So the way I do this is the first thing I'm going to do is subtract that 40,000 from both sides. And I get 27,000 is equal to n minus 1 times 3,000. So the next thing I would do, you could distribute this 3,000, but I'm just going to divide it out. So when I divide that out, I'm going to come over here and I get 9,000 is equal to, oh, I'm so sorry, not 9,000. 9 is equal to n minus 1, and then I'm going to add 1. So n is equal to 10. So that means in year 10, that's when he'll make the 67,000. Okay, now let's go on to recursive. So this was like the other like weird way of doing things, but it's not hard, it's just different. So when you see a plus, that means that you're going to add 10 to everything. If you see a minus, you're going to subtract 10 to everything. If you don't see anything or you see that little dot, that means that you're going to multiply whatever by any for like all your terms. Okay, so is each of the following arithmetics? Okay, so this is, we kind of already talked about that. That is arithmetic and this is geometric. Because, and again, because this is addition, this is multiplication, then write the first four terms of the sequence. Okay, let's see. 29 plus 10 is 39, plus 10 is 49, plus 10 is 59. Okay, so those are the first four terms of the sequence. Okay, this one over here, we're starting with -1, and then we're multiplying that times 2. So I have -2, and again, times 2 is -4, times 2 is -8, times 2 is -16. Ooh, I think I went too far. I did. Let me just do this. Okay, let's keep going. So now we're going to go backwards, and we're going to write a recursive rule. So that means it's going to look like one of these up here. So I have to figure out my pattern. So it looks like this one, I'm adding 3 to everything. So I'm going to use this one. So I'm going to say we always have to call our first term. So a sub 1 equals 29. And then I'm going to say a sub n equals a sub n minus 1 plus 3. Like that's that pattern. Okay, this one I am multiplying by 2, so now I'm going to use this one over here. So I'm going to say g sub 1 equals -1, and g sub n equals g sub n minus 1 times 2. And you could put it in parentheses as well. It does not matter. Okay, and then finally, number 11. Yeah, look at this. We're dividing by 2 everywhere, but remember, we can't say dividing by 2. We have to say multiply by 1/2. So it's multiply by like 1 over whatever you're dividing by. So we're still going to use that g, the geometric one. So I'm going to say g of 1 equals 224. And all of this is going to be the same, except 2, instead of 2, I'm going to say 1/2. And that's it. So these, let's see, up here, this one should be 1, and this one should be 1. Okay. Next page. Now we're going to transition over into statistics. So notice we have the scatter plot here on number 12. And notice it's kind of like, if I can make it like a rough line of best fit, it's going to do something like that. So as the vehicle speed is increasing, the traffic volume is decreasing. Okay, so which statement best describes the relationship? Okay, as traffic volume increases, the speed decreases. And I totally said that backwards, didn't I? Okay, so here, so if we have like a high vehicle speed, our traffic volume is here, is like at its most. And then, okay, I'm going to try this again, guys. I'm having issues. Okay, so as like, let's pretend that this is like 120. What does that mean? Well, it means that our traffic volume is low, but our vehicle speed is high. But as we get down here, I might have like 10.5. That means like our traffic volume is higher, but our vehicle speed is lower. So bottom line, it's like as our traffic volume increases, our vehicle speed is decreasing. Okay, so let's see. So that means it can't be that one. Oh, there it is. It's right there. It is number 12. Okay, let's look at number 13. So number 13, I am going to type this into Desmos as a table. Okay, so how I do this is I push this plus button here and make a table. And then I'm just going to put these values in. Okay, so it looks like something like that. Okay, now I'm going to get the equation and look at the correlation coefficient. So the correlation coefficient is this R right here. And 0.7267 means that there is a positive correlation, because if it were negative, like let's say like this one over here, it would be a negative R. But it means that it's about like 72% correlated, 73%, something like that in there. And so when it asks for like what is a correlation coefficient and what does it mean, I would describe the type of correlation. And so like if you're getting up to like the 90s or like like 0.9 something, I would say it's like a strong positive correlation. But for this one, I'm just going to say it's a positive correlation. Okay, and then what is the equation in the line to best fit? So I'm going to go over here and I'm just going to round it. So I'm going to say y equals 0.46x and then plus 2 point, I'm going to call it 43. And then if using the previous equation, predict the number of free throws if there are 21 students. So I always ask myself, is it giving you an X or Y? Well, it's giving you the number of students, so it's giving you an X. So I'm going to come over here and I'm going to copy this equation, and then I'm just going to plug in 10 here. So it looks like this. And then if you'll notice, it tells you the answer. So predict the number of free throws. So I'm going to say like between 5 and 6. Okay. Let's go ahead and go down to number 14. And so we talked about data being skewed, and so it's always opposite of what we think. So if all your data is here on the right, then I'm going to say skewed left. It's always opposite. Okay, and then number 15, it says the table below is a summary of obedience training at PetSmart. What is the probability that a puppy will be in the Thursday class? So more general, it's a puppy, so I'm only looking here. Like I'm not looking anywhere else except right there. So 22 total puppies, that's going to be on the bottom of my fraction. And then I'm specifically looking for the one in the Thursday class, so right there. So I'm just going to take my calculator because it asks for probability. So I'm going to say 9 divided by 22. And I get about 0.409. And I'm going to change this to a percent. And so notice on your calculator, it's like the right-hand parentheses. So if you did like the second and then the right-hand parentheses, that would give you about 40.9%. Okay, let's go on to the next one. So I'm looking at number 8. And this one is kind of a tricky one because we're trying to figure out, it says like which type of mosaic has a greater median. So we're trying to find that middle point. So what I would do, I don't know, I would call this like maybe 1 and this 2 and this 3 and this 4. And I'm going to do the same thing down here. 1, 2, 3, 4, 5. So these glass mosaics, I'm going to come up here. I'm going to say, let's see, there's 2 1s. So I'm going to say 1, 1, and then I have 5 2. So 1, 2, 3, oops. 3, 4, 5. And then let's see, 4 3s. 1, 2, 3, 4. And then 1 4. Like that. Okay, let's do the same thing with the ceramic. So I have, let's see, 1. And then I have, let's see, 4 2s. 1, 2, 3, 4. And then 3 6s. So 1, 2, sorry, I said that backwards. 6 3s. 1, 2, 3, 4, 5, 6. And then 1 4, 1 5. Okay. So let's go ahead and find the median. So the median is the exact center number. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. Okay, so my median here is in here somewhere. Okay, let's go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7. Okay, so my median for the ceramic is in that blue one. Okay, so the median, okay, so I'm looking at my answer choices. So the median for the glass mosaic is greater. Nope. The median for the glass mosaic is less than. Yes. It's not the same and it can be determined. Okay, so it is answer choice B. Okay, we also talked about something that's correlated versus causal. So it says, which of the following correlations shows a causal relationship? So height and intelligence, no. Shoe size and running speed, no. The number of correct answers and a test score, yes. The number of students in a class and the number of students with A's, no. So this is the only one that this causes this. So that's why it's causal. Okay, let's look at number 7. So we're dealing with a bar graph and I'm sorry, a box and whisker. Okay, so the mean, so we don't know the mean, but a lot of times with a box and whisker, your mean's going to be like right there, like right in the middle of your box. So the mean is equal to the median, probably not. The mean is probably less than 30 miles per hour. Yeah, I'd say yes. The mean, and it says select all that apply. So I'm going to say it's not more than 30 miles per hour. If an officer captures an additional speed of 70 miles per hour, the mean must change. Yeah, that's absolutely going to affect the average. Yes. What about the median? No, that is not necessarily true. If you have like multiple, let's go up here. So if we added like one more onto this data, so let's add another 5 here. Do you see it would just move to here? And so it's not going to like really affect the mean, or sorry, it's not going to affect the median at all. It could, but it's mainly going to affect the mean. Okay, so let's see, let's review. So B and D are my answer choices. Okay, let's go to number 8. So we have another scatter plot, and this is another select all that apply. So let's look at this. So the number of missed school days, and then, okay, and they're comparing that to grade. Okay, the number of days missed has no correlation. That is not true. We definitely see, and this is a negative correlation because it's going downhill. A student with perfect attendance, okay, so let's see, this right here, perfect attendance, is expected to score about 98% on a math final. Yeah, I would call that 98%. Yes. Okay, the student with perfect attendance is expected to score approximately 38%. No. For each day a student is absent, that student's final exam score is expected to decrease approximately 6 percentage points. Okay, so basically this one's asking for the slope. So let's see. So if we're going from 98 to like here, let's see, I'm going to erase this real quick. Yeah, I would say yes, that's true. So that one, for every 6th day the student is absent, okay, so we're right here, the score is expected to decrease 1%. No, it's decreasing a lot more than that. Look at that. It's going like down like 40%. So no. Okay, so it's B and D for our answers. And let's go on to number 9. This talks more about like the correlation coefficient. And so notice all these on top are positive. So this is like, if it's perfectly in line, that's a 1. And this one right underneath it, that's going to be a -1. So they're equally like as correlated as the other one. One is just a positive correlation and one is a negative correlation. So I'm going to kind of work backwards. So this one would be like 0.98. This is a strong positive correlation. And then let's see, this one, that would be R equals negative 0.92. This one is R equals 0.69. And this one is R equals negative 0.64. And this one is R equals negative 0.08. And this is R is equal to 0.33. So notice these, like, they're hardly correlated. Well, I mean, they're really not like we couldn't, this would show prove that like there's no correlation between the two things that we're testing. Okay, let's go on to number 10. This is that weird one. Residual is defined as the difference between the actual value of the dependent variable and the value predicted by the model. Okay, so look at this. Like, really, you don't need to know any of that. Just know that this is the only one that really makes sense. Like, it's the only one that goes through your data. So just kind of stick with that. Okay, explain which graph is better and why. Okay, guys, do you see this? Like, this is not changing very much. And so this looks like it's like hugely increasing, but it's not. Like, it's about the same. Like, this is the more accurate data. So I'm going to say, like, it's better to start at 0 degrees and like incrementally go up. Okay, let's do this. Okay, so we need outdoor carpet. So I'm going to make a rectangle. Okay, so this is 2.75 yards by 2.25 yards. Okay, and I know that 1 yard is equal to 3 feet. So what I'm going to do is I'm going to multiply this by 3 and I'm going to multiply this by 3. Okay, and I get these values in feet, and that's what I need because it says that she found this company that sells in whole foot increments. So carpet, that we need to find area. So we're not just doing perimeter, we're actually like covering the area. So what I'm going to do is say 6.75 times 8.25. And I end up with 55.6875 square feet. And so I can't like it, I need to round to the nearest whole foot. So I'm going to round up to 56 square feet. Okay, the last page we're going to talk about is simplifying radicals. So remember, like this, you can type into your calculator and make it do the work. So square root of 80 is 4 square root of 5. And then I'm going to ask myself, how many times does 2 go into 6? So 2 goes into 6 evenly 3 times, and I'm not going to have a leftover. So I'm going to cross them out. Okay, 2 goes into 9, let's see, 4 times, but I am going to have a leftover there. So all of this goes on the outside. So I have 4x to the third, y to the fourth, and then I have square root, let's see, what do I have on the inside? 5y of 5y. Okay, let's do this again. Let's do this for number 2. So I'm going to say 8 square root of 125 is 40 square root of 5. So I'm going to first of all simplify this as 40 square root of 5. And I'm going to say m to the 16th n to the 8th. And I'm going to put a little 2 here. And so I'm going to say 2 goes into 16, 8 times evenly. Okay, so an m to the 8th is going to come out. And 2 goes into 8 4 times evenly. And so I'm going to have all of these on the outside. So I'm going to say 40 m to the 8th n to the 4th, and then square root of 5. Okay. Number 3, you are able to just type this whole thing in Desmos. So let's go ahead and do that. We're going to go back to Desmos. Oops. Okay, and Let's type it in as we see it. The square root is down here. So it looks like that. 3x plus 4 is equal to negative 12. Okay, and notice I have this thing, and I can't really tell, so I'm going to zoom in. Oh, and it looks like it is 4. So my answer is going to be x is equal to 4. Okay, we're going to do this again, and notice how this one has an n, but I'm not going to use n, I'm going to use x. So let's see, minus 3. And then I have that minus 1 on the outside is equal to 9. Let me make sure I did that right. Okay, and so let's zoom out a little bit. Oh, okay, so we found it. Let's zoom in. And it looks like this one is 14. So I'm going to say, I'm not going to say x equals 14. I'm going to say n equals 14. Okay, and these 4 down here, you can literally do in your calculator. So this one is 4 square root of 5. This one is 7 square root of 2. This one over here is 5 square root of 3 plus 3. This one over here is square root of 14 plus 8 square root of 2. Okay, and then finally, we have these last two. And let's kind of start with the transformation. So the first thing I noticed about this is it's going right 4 and down 2. So right 4, down 2. This is the one that like your domain and your range is weird. So we're going to hold off on that. I'm going to go ahead and type this into Desmos. So I'm going to say y is equal to the square root x minus 4 minus 2. Okay. So guys, notice that I'm going to bring this down. Notice that it has a definite starting point. Okay, so this starting point is positive 4, negative 2. And I'm getting it from this. Remember, never trust your x's. So positive 4, negative 2. That is going to be the first plot in my XY chart. So positive 4, negative 2. Okay, it is also going to be my domain and range. So on this one, do you see how, okay, I'm going to move this over. Do you see how like everything is going up? So my x's are increasing, my y's are increasing. So I'm going to say x is greater than or equal to, and then I'm going to take that number, 4, and then y is greater than or equal to negative 2. So those are my domains and range. Let's keep going. So I want some more points. So I'm going to go here and make a table. And notice like Desmos literally just starts throwing out stuff. So I want it to be stuff that I want. So let's see, there's 5, negative 1. I like that. Okay, let's keep going. 6, nope, 7, nope, 8. Ooh, 8 is 1. 8, 0. Let's try to find one more. Oops. Okay. I'm just literally just going down. Oh, there it is, 13, 1. So that's probably too big to fit on our graph. So I'm going to, okay, I'm just going to plot these points. So 1, 2, 3, 4, and then negative 2, and then 5, negative 1, and then 8, 0. So it looks something like that. Okay, over here, this is our last one. So let's see, vertical flip. Let's see, right 3 and up 1. So I automatically know, and you can see this on Desmos if you can't tell it, but I already know that my starting point is going to be 3, 1. And then my domain is going to start there. So x is greater than 3, but my range, because of this vertical flip, is going to be y is less than or equal to 1. Okay, and on this one, if you type it into Desmos, I'm gonna get, let's go ahead and do that. I'm gonna get this, and let's see, I'm looking for those nice numbers. So I have 3, 1. Let's see, 4. Ooh, there's another one, 4, 0. Oops. Okay, let's keep going. 5, 6, 7. Oh, 7, -1. I like that. And then let's see, let's keep going. There's 12, but that's off the graph. So we're just going to graph what we have here. Okay, so whew, got big. Okay, so 3, 1, 1, 2, 3, 1, 4, 0, and then 7, -1. It's going to do something like that. And that is it, guys.